What if you could build your own AI dream team? A whole crew of specialized assistants, each one an expert in its own field, all working together to build your software. Well, that's not science fiction anymore. Today, we're going to look at a new workflow that helps you build better and faster, and honestly, save a whole lot of money and headaches along the way. If you're a developer who's been using AI to code, this has probably happened to you. You're in the zone, you're making amazing progress on a new feature, and then bam, you hit your API limit. It's a super common frustration, and it's not just costing you credits, right? It's killing your momentum.
And this really gets to the heart of a major dilemma in AI-assisted development. The most powerful models they're incredible for writing complex code, but wow, can they be expensive. That cycle of coding, hitting a bug, and then reprompting the AI over and over again to fix it, that can just torch your budget before you even know what happened. And just take a look at this real-world example. A developer used a really powerful AI coder, an agent named Claude Code, for some initial planning and to write the first draft of a feature. And the result? Almost a quarter of their entire weekly API limit gone. And get this, that was before the real work of debugging had even started.
So there's gotta be a better way, right? Well, what if instead of having one brilliant but super expensive AI trying to do everything, you had a lean, specialized team? Imagine each AI agent just tackling the one task it's amazing at. You'd get a workflow that's way more efficient and a whole lot cheaper. So here's what that hybrid workflow actually looks like in practice. It's a 3-agent process. First, an AI like Gemini, which is great at research and big-picture strategy, it lays out the whole plan. Then, that detailed plan gets handed off to a coding specialist like Claude Code to write the actual code. And finally, a dedicated testing agent, in this case one called TestSprite, steps in to systematically find and diagnose any bugs. So, you might be wondering, how do all these different AIs talk to each other? Well, the magic behind it is a technology called the Model Context Protocol, or MCP. The best way to think about it is like a universal adapter for AI. The source material even calls it the USB-C for LLMs. Just like a USB-C cable lets you connect all your different gadgets, MCP creates a standard that lets different AI models and tools plug into each other and work together perfectly. All right, so theory is one thing. Let's see how this whole workflow actually performs in the real world. We're going to walk through a super common development task, adding a user sign-in feature to an app. So first up, Gemini takes on the role of project planner. It researches the best authentication systems out there and then creates this really detailed roadmap. Then, that roadmap gets passed to Claude Code, who acts as the lead developer, taking that plan and hammering out all the code for the new feature. But, as any developer watching this knows, the first draft is almost never perfect. And this is that critical moment where the real cost of AI development can just sneak up and ambush you, because now you start burning through those expensive credits just trying to fix bugs. And this leaves you at a fork in the road. You can either keep going back and forth with your expensive primary AI, which costs a lot and takes a ton of time, or you can bring in a specialized, low-cost testing agent that gives you instant, precise feedback to get the job done efficiently.
And to put some real numbers on this, in our sign-in example, just one round of manual debugging, a single prompt that said, "Hey, this isn't working, can you fix it?" ate up another 6% of the session's API limit. Just think about how quickly that adds up over dozens of little bugs.
This is exactly where that third agent in our workflow, the automated testing tool, comes in and just completely changes the game. So the developer brought in TestSprite, the automated agent. It immediately ran a full suite of tests on that new sign-in feature. And as you can see, it did not take long at all to find several specific things that were failing. And here's the crucial part. Instead of just a vague, "it's broken," the developer gets this detailed report that pinpoints the exact errors, and it even comes with visualizations of the test runs. This just completely takes the guesswork out of debugging. It saves so much time and so many credits. So, armed with this super specific bug report, the main AI, Claude Code, was able to make a quick, surgical fix. The developer reran the automated tests, and what do you know? 100% success rate. Problem solved, just like that. Okay, so let's zoom out. What does this all really mean for the future of building software? What's the big takeaway from this hybrid, team-based approach? Well, the benefits are pretty clear. You save serious money by using your expensive API credits way more strategically. You find and fix bugs in a fraction of the time. And maybe the most important thing is that your role starts to evolve.
from just being a coder to being the manager of a highly efficient AI development team.
And that really leaves us with a fascinating question about where all of this is headed. As these AI tools get more and more powerful and specialized, is it possible that the most valuable skill for a developer won't be writing perfect code, but being an expert at conducting this orchestra of AI agents to build something amazing?